Hello everyone, welcome to today's edition of Migrating Enterprise Database Lab. For today, we are exploring running databases in GKE. GKE means Google Kubernetes Engine, and in this lab, I'm going to show you how to deploy a database into it, and we are going to explore two ways by which you can deploy a database to our Kubernetes. The first one is using our own configuration code, and the other one is using a Kubernetes package manager called Helm. Before we dive into this lab, I'm going to do a quick explanation of what Kubernetes means, the advantages of Kubernetes, and I'm going to explain Kubernetes cluster. Kubernetes is an open source cross-platform framework for running applications inside a cluster of shared resources. Kubernetes automates the deployment of containerized app. The configuration files specified describe what you want, and Kubernetes ensures that this is what you get. If your deployment becomes out of sync with the configuration files, Kubernetes fixes it. And if the configuration is changed, Kubernetes changes the deployment to match the new configuration. Some advantages of running a database in Kubernetes, or just some advantages of using Kubernetes. The first one is automation of compute infrastructure. Another one is open source cross-platform. Because Kubernetes is open source, you can integrate with a whole lot of other tools. Kubernetes is supported by AWS, Microsoft Azure, and Google Cloud Platform, GCP. And it's also run on-premise for hybrid deployments. Kubernetes clusters consist of master and worker nodes, in the sense that instructions are sent to the master using the Kubernetes CLI, and apps are run on the worker nodes. Because we are using GKE, which is a managed deployment of Kubernetes, GKE automates the creation of Kubernetes clusters. So let's get started and see what we are going to do in this lab. Our objective, once again, is to create a GKE cluster, deploy MySQL on the cluster, and use Helm to deploy MySQL on the cluster. So as usual, start our lab. So our lab is starting. So we'll open in an incognito window. Then copy your password. Click on next. Paste the password here, enter. Here is our dashboard. Great. Let's get started. So the first task is to create a GKE cluster. And to create a GKE cluster, I'm just going to follow what I'm doing here. So when you're on Kubernetes engine, move ahead and click on cluster. So where it's going to load. When you're on cluster, click on create. Then we are using a manage, just configure it. So this lab told us to use the default requirements that are here, so I'm not just going to change anything. But if you want an equivalent REST command of what you've done, you can click on REST and you get an equivalent REST command that you can use with an API call. And if you also want a command line version, you can click on command line version, and you have this that you can just paste on your command line. But I'm just going to do that from the UI. I'm going to click on create. It may take a while for our Kubernetes cluster to get created, so sometimes it takes 2 minutes. I'm going to see you at the end. Yes, our cluster has been created. So the next thing we have to do is to connect into the cluster. So to connect into the cluster, from here, you click on connect. After clicking on connect, then this is the command line that we use to configure our cluster. So you can connect to the cluster using this command line. So I'm going to run this command line in Cloud Shell. It's going to run automatically there. So it's provisioning our Cloud Shell machine. Thereafter, it will connect to our Cloud Shell instance. Yeah, fine. It's pasted the code. Click on enter. And I authorize this. So our kubeconfig entry generated for cluster 1, which is what we need. So the next thing we want to do is We want to test the connection using the Kubernetes command. We want to see how many nodes there are here. We created 3 nodes. Let's see if we are going to see 3 nodes here. You can see the number of nodes on top. Just going to run this code. Yeah, so you have the GKE cluster 1, GKE cluster 1, GKE cluster 1. So these are 3 nodes that we have. Fine. So let's check if we've completed this, which is creating a GKE cluster. Now that our GKE cluster has been created, the next thing we want to do is we want to deploy MySQL into it. So to deploy MySQL into it, we'll store the password as a Kubernetes secret. So this secret is a key value pair, and in this case, the key to the password is the root password and the value is password. I'm storing this in a Kubernetes secret. So with this command, Kubernetes create secrets, generic SQL secrets. So this is the key and this is the value. I need to paste this here. So the secret has been created under MySQL secret. The next thing we want to do is we want to make a directory, which is MySQL -GKE, and we'll cd into that directory. So it's from that directory that we are going to be operating. So we've made a directory and we've cd into the directory. So the next thing we want to do is we want to open our editor. So open your editor in a new window. So we've done that. So this is where our configurations and YAML file will be on. So this is the folder we created. So you can just see it's still an empty folder. So the next thing I want to do is I have to create the YAML file, and YAML file is used to configure an app to run in a Kubernetes clusters. So let's see. So the first thing we have to do is we have to create a volume.yaml, and the function of the volume.yaml is to configure a disk space, and it uses a persistent volume claim. It also helps us to reserve disk space on the cluster used by our database. And you can see this is it's a read-write one. It's a read-write disk, and it's using this deployment. So the next thing we will do is we'll create a file under the folder that we've created. The file will be named volume.yaml, and so let me just do that. Create a new file here, volume.yaml, click OK. Then I'm going to copy this code and paste it here. So after that, I just need to do Ctrl S to save it. So the next thing I want to do is to also create our deployment.yaml. And what the deployment.yaml helps us to do is, among other things, it helps us to specify what Docker image we want to run. It also helps us mount the volume claim and specify paths. It also helps us to configure environmental variables, because if you take a look at this, you would see it here. This is the volume mount that I talked about, and these are the environmental variables that we used. So you can see that in here we are not specifying our password. So it's a bad practice to specify your password especially the password to your Kubernetes cluster in the config file. So it's a bad practice. So I'm supposed to maybe create an environmental variable for this user that is here, but I've created a Kubernetes secret for my root password, and that is why you can see I'm not specifying the value here. It's going to get the value from the secret that I created, and this is the name of the secret, MySQL secret. So this is what the deployment is used for. And another function of the deployment, it shows the MySQL version we are working on. So you can go down a little bit and you are going to see the version of MySQL that we are working on. So this MySQL that we are creating is using a MySQL 8.0 image, and that's the image that's going to run. That's the image property that's going to run in the cluster, and it also has a container port. So this is just the default container port property for Kubernetes here. This 3306 when you are using a DB. So just the same way we did the other one, we'll create a deployment.yaml file and we paste this code into it. So let me just copy this, go back to our editor, create a new file, deployment.yaml. So when I'm on my deployment.yaml, I copy this code here, paste it into it, then as usual, Ctrl S. So the next thing I have to do also is to also create a third file, which is the service.yaml. And one of the benefit of creating a service.yaml is that it provides access to the database running in the cluster from the client app that needs to connect to it. So it provides the required access to the database running in the cluster from the client app that needs to connect to it. So typically, clients don't connect directly to the app in the cluster. They just connect from the service that has been created. And each service comes with an IP address that poses request to the deployed application. And if you take a look at this service.yaml, so when under it, you see this in it when it gets created, it will be assigned its own service, its own IP address that will poses the request to the deployed app. So I'm just going to copy service.yaml once again, just the way we did the rest. I'm going to create a new file. Name is service.yaml. So thereafter, copy this into it and click on Ctrl S to save it. Yeah, so we've done the required. So the next thing we want to do is, if you want to confirm if everything that we created are actually there, so I'll go back to the Cloud Shell and I'll just do an ls command to see if what we asked him to create has been created. So just from our terminal, just use ls. So I'm just going to reconnect my terminal. So when your terminal idle for a while, you may have to reconnect to it. So with the ls command, click enter. So you can see we have the deployment.yaml, we have the service.yaml, and we have the volume.yaml, which shows we are good to go. So the next thing we want to do is to deploy our database. We have to run this command. So we specify the configurations files in the YAML that we created for the volume, the deployment, and the service. So now let's deploy them, which is the 3 of them. You can see that the persistent volume claim is created, the deployment app is created also, and the service is created, which shows we are good. So we have to wait a bit before we run the next command. So I'm just going to chill a bit before I run the next command. Yes, so I'm back. The next thing, I use the Kubernetes get board. So with the Kubernetes get board, you can see that the status is now running. So if you do it too fast, the status may not be running. So that's why I had to wait a little bit before I run this. So let's check if we've completed this. Just going to wait a bit. Yes. So we've deployed MySQL on our cluster. So the next thing we want to do is I have to copy the name of the pod that was created because I'm going to use it here. So this is our name of this is the name of our pod here, this one. But let me paste this first. So when I copy this and paste this, then I have to replace this part with the name. So when I come here, I copy this. I've copied it, then I paste it here, and you can see that I've used the name of our cluster here. So click on enter. So now we are on the bash command, which shows that it's working. So let's log into our MySQL like this. So this is, and the password we created then was password, the one we specified. So I'm just going to use it. Yeah, you can see that I'm in our Kubernetes. I'm in our database now. So, and when you're in your database, the next thing you want to do is you can show database. So this is not part of the lab, but I'm just going to do it so that you can be sure that our database has been created. So when you show database, sorry, it's this. You can see this. These are some examples database that are here. So let me create a new database. So to create a new database, so let's confirm this is create database as expected. Yeah, so our database has been created. So if you want to put some information into this database, we have to first go into that database. So to go into the database, you use, then specify your database that you are the database in question, which is in this case is engineer Qwiklabs. So now you can see that database has been changed. Then table in my database. So when I paste the code to create a table, I click on enter, and you can see that it has created my table. So what this code is doing is that it's creating a table named pets. It's using an ID of int auto increments, and this ID column, it's creating 3 columns: the ID, the name, and the breed. So I'm auto incrementing this ID. So when a new information get added, it's just going to auto increment the number as number 2, number 3, thereabout. So I'm creating a column name for name and another column for breed. So this is it. So I was copying the wrong thing here, and that's why there are some error above. So you can just copy this code here and paste it there to create a new table name. So another thing is, if you want to insert new record into your database, so you can just say insert. You can use insert into, then you use the name of your database. In this case it is pets. I'm going to paste, and then I'm going to use the name. So we have name and breed, which are the 2 columns that I have. The other one is auto incrementing. Then I'm going to use the values. So these are for the values that I want in this. So I'm going to create 2 entry. So the first one is maybe Ole. So it should be in inverted comma, then maybe the breed is yo, just using some random values. Close the bracket. Let me create a new entry. Let me use this one as tie. I'm going to close this. Then some other one. Let me use then close this. So this is just this is 2 entries that I'm creating in our database, and don't forget to close this, then click on enter. So you can see it says query OK tools affected, no duplicates, no warning. So I've input 2 records. So if you want to confirm if these records are actually there, then you say show, or no, you do select, just like you're writing an SQL query, select star from the database name. You can the table name, you can tell me the table name. The table name is pets. So I forget to add this, and you can see, the ID is auto incrementing. I did not specify this, it's just auto incrementing, and these are the 2 values that I entered, which shows that our MySQL database actually works. So I'm going to exit from this. Yeah. So these are just some things that I added on my own, and you can see here are some of it here. So the next thing is to remove everything that we've created, to delete the MySQL database that we created on our GKU. Just going to run this code here. No, I have to exit the bash first. Sorry, exit the bash. After exiting the bash, and I run this code, and it's going to delete. You can see it has deleted my service, deleted my deployment, and also deleted the persistent volume claim, which shows that we've deleted our database on the GKE cluster. So let's keep going. So for task 3, we want to use Helm to deploy MySQL on the cluster, and just a brief intro of what Helm means. Helm is a package manager for Kubernetes. It simplifies deployment of database to a Kubernetes cluster. Helm is an open source package manager for Kubernetes, similar to the apt-get or the Yum on Linux. So Helm clusters are used to package Kubernetes config files. So you can create an Helm chart of your own, and you can also use from the pre-configured files that Helm adds. So there are a lot of pre-configured deployments for hundreds of applications, including database like MySQL, SQL Server, and PostgreSQL that are already pre-configured for us on the Helm charts. But trust me, you can also create your own. And the good thing about Helm is it's already installed on Google Cloud Shell, so you don't need to install Helm. You just need to initialize Helm. And after you've initialized Helm, then you can use the install command, and you specify the name of the Helm chart that you are installing at that particular time and the parameters that are required. So if you also need some Helm charts, you can check the Helm Hub website for some Helm charts, but that's beyond the scope of this lab. So we are using a Bitnami Helm repository to your cluster. So to paste this repo here, so I'm going to connect my cloud share. So paste this here. Start pasting. You can see that it works. Let me refresh this with this. Yeah, so you can see that when we run this repo at Bitnami, you can see that Bitnami has been added to our repository. So the next thing we want to use is we want to update the package. So you can use the repo update, and it's going to grab the latest information that we have. Next one is we want to install a MySQL named MySQL using M. So this is the name of the M chart that we are using. This mydb bitnami /MySQL. So using this command, and you can see that it's going to remove the pain of doing the whole configuration that we did the other time when we are using this. So we have to follow these parameters to see if our MySQL database will get installed. So the next thing we want to do is just follow everything here. So the first thing I want to do is just going to do it one by one so that you don't get to echo this. So after echoing this is the primary DB. The next thing is I would execute the following to get the administrator credentials. So I'm going to do it one by one. I'm going to echo this first, and you can see our username is root. So I'm going to echo this other one also. Sorry, I'm just recopy this. Okay, so I'll add echo at the back. Still not copying. Let me copy it. I'll get copied now. So paste this here. Okay, so let's echo this, and you can see this is our password, this thing here. But since we've echoed it, we should be able to use it when we want. So the next thing is to connect to our database, and to connect to our database, we run this command here. So let's follow the instruction. They are pretty basics and do it one by one. So here we are. This is the database that we want, and the next thing is to connect to this one. We use this command, which is the last command here. So it's going to enter it here and click on enter. So it's asking us to enter password. So this is the password that we have here. You can just copy it, paste it here, click on enter. So now we are on our MySQL database, and you can see that this is even quite very easy than the previous one that we had to do. So the similar thing we did on the previous one, let's just try it out here. The first thing I want to do is let's show our database. So I'm not going to do majority of what I've done before. I'm just going to do some of it. So let's show our database, and you can see our database. These are the pre-configured database that comes with this Helm package: information schema, my database, MySQL performance schema, and sys. So you can, let me create a new database and stop there. So use create database. I'm going to name it comment db. I forgot to have this, and you can see this. So if you want to confirm if you've created this, just do the show database once again. Show databases. So you can see now we have this comment db that we created. We have it here also. So this is to show that our database has been created and using Helm chart. So you can see that this was pretty faster than the other one, and it also get created on Kubernetes. So you can use Helm charts for a lot of things. You can use Helm chart to install a different thing on Kubernetes cluster, not only databases. You can use to install apps, a whole lot of things. So make sure you check the M charts, and make sure you check the MHub website for the different M charts that are available for your respective application, to save you the stress of doing it once again. So I'm going to check my progress and see if I've actually done this. Yeah, you can see that I've done this. So the next thing I want to do is I want to list the deployments that are in our M chart. So you can just do this is probably not going to work because I'm still in the database. So what I'm supposed to do is I'm supposed to exit the database before I run this. So let me exit the database. Yeah, so after exiting the database, let me see if I think I still have to press and exit one more time to exit this. Yeah, so now this has been deleted, so I can now do an Helm ls here, and let's see. So you can see this is the M chart that we created. MyDB, it's deployed already. So, and this is the version of MySQL 8.0.32. So since we are done, we have to delete it. Just going to run the delete command. Oh, I've lost connection. To reconnect one more time. So when you lost connection to your database, when you lost connection to your cloud shell, just then reconnect and paste this one more time, click enter, and you get a notification that it has been deleted. So this has deleted. So one thing you can do is if you notice that your cloud shell is showing in a muffled way, just refresh your browser. So when you refresh your browser, you'd see that it's going to align it as expected back. So just wait and see. So I'm just going to dismiss this, and you can see that it's aligned now. So this is the delete, and this is the release MyDB uninstalled. And that's pretty all we want to cover for this lab. So you've seen how we can deploy Kubernetes cluster, and we created a Kubernetes cluster and we deployed a MySQL database into it using the configuration code, and we're using our own configuration code, and we also used an Helm chart to do that. So this is really interesting. This can help you have a solid foundation of how to run databases in Google Kubernetes engine, or just basically how to use an M chart on Kubernetes. So if you really enjoyed this lab, make sure you like it, comment your thoughts in the comment section. Let me know what you think about this. Share your thoughts, share this lab to your loved ones or to those who may beneficial to it. And don't forget to subscribe to my channel. Bye for now. See you in the next lab.